forward. Okay, so vectors. So in general, if I want to just say in mathematical terms, so vectors, at least in real vectors, they are basically ordered numbers. So two-dimensional vectors, you have a pair of numbers. For three-dimensional vectors, you have a triple of numbers. You can have four-dimensional, five-dimensional. So you have a list of numbers that are ordered. So here, order is important. For example, we have vector 2 and 1. The components are 2 and 1 is different from 1, 2. Okay. So in two dimensions, so two-dimensional vectors, I just put right here, two-dimensional vectors. So if you have any vectors like u, it has two components. So I would just say u1 and u2. For three-dimensional, so vectors, they have, as it sounds, you have three components like u1, u2, u3, and so on. So you can have higher dimensional vectors, okay? So, but there are two fundamental operations with vectors, and one is adding, vector addition, and another one is scalar multiplication. What is vector addition? That is whenever you have two vectors like u and v equal to v1, v2, and v3, how we add the two vectors? So we say, the phrase is, we do it component-wise. Component-wise. Component-wise means we basically add the each corresponding components. So the addition is done component-wise. So that is u plus v equal to u1 plus v1, u2 plus v2, and u3 plus v3. That is addition. You can also multiply a vector by number. For example, you can multiply u by 2. That is also done component-wise. That means it's 2 times u1, 2 times u2, and 2 times u3. So in general, if you have a number c is a real number, then c times u is a vector, is c times u1, c times u2, and c times u3. So in particular, if you have like a 0 times any vector u is just, or 0 vector. So 0 vector, remember, 0 vector is different from 0 as a number. Because numbers, they only have one component, like 1, 2, 3. But vectors, they have several components. It's like a list. Okay. Okay, guys. So that is fundamental operations with vectors. So addition and scalar multiplication. Maybe later I will also teach you the dot product or the inner product. Have you seen the inner product before? Yes. Yeah. The dot product, maybe it's just, let me tell you. The dot, whenever you have two vectors like u, v, consider these two vectors. in 3 dimensions. But what I say is not limited only to 3 dimensions. You can also do this in 2 dimensions. You can also do this in 4 dimensions and so on. Okay. So the dot product or the inner product is called the dot product or the inner product sometimes. And we denote it by like u dot v. It's a number. So the dot product of 2 vectors is a number and is defined by u1 times v1 plus u2 times v2 plus u3 times v3. So you just multiply the components and then add them. Okay. Is that clear? Is that this definition clear? So for example, if you have like these 2 vectors, u equal to 1, 0, minus 1, and v equals to 2, 4, 1. What is u dot v? Tell me. U dot v is equal to 1 times 2 plus 0 times 4 plus minus 1 times 1. That is equal to 1. So the dot product of any 2 vectors is just a number. So this is, you have to remember this. Okay. Okay, so here was the dot product. Another important thing is, so whenever you have vectors, for example, in 2 dimensions, imagine the 2-dimensional vectors. So first of all, from the point of view of geometry, you can correspond 2-dimensional vectors to the points on the Cartesian plane. And you know how to do it. The vectors, the components, are just x, y components of the points on the plane. So that means if you have any point like this on the plane, you can correspond the vector to this point. You just join the origin to that point, and that is a vector. What are the components? The components are of this vector are just the xy component of this point. So for example, if this is x and this is y, then this vector, I just called it u, is equal to x and y. It has 2 components. Okay, so something important is, first, what is the magnitude of a vector? So the magnitude of a vector from the point of geometry is the length of this vector. So we usually denote the magnitude, if you have a vector u, we denote the magnitude by absolute value. Or when you go to university in more advanced text, we also sometimes denote it by like this double line. We call the norm. But they have the same meaning. All of this notation have the same meaning. And that is the magnitude or the length of the vector. Okay. And how it's defined? So for example, in 2 dimension, you just use Pythagorean theorem. So the magnitude of u is equal to x square root of x squared plus y squared. If you have a vector in 3 dimensions, say that u1, u2, and u3, its magnitude is given again by similar formula, but here you have three components. u1 squared, u2 squared, plus u3 squared. And then you take the square root. Okay? So another important thing is, in two dimensions, you can talk about the angles. Like theta. Theta is the angle that vector makes with the positive direction of x-axis. Okay? So can you tell me the relation between x, y, and the magnitude of the vector using theta? So let me tell you the first relation is that x is equal to the magnitude of u times cosine theta, and y equal to the magnitude of u times sine theta. Right? Is it clear? Okay. So I also talked about the projection. So remember these two. So here is, you have basically two vectors. Imagine that you have two vectors uv. Imagine that this is u and this is v. And you know what is the angle between u and v. Imagine the angle is theta. So now the question is, here I want to decompose u in two components. One is in parallel to v and one component perpendicular to v. So our task is to decompose u in two components. One is the parallel part. So I just say u parallel, and one is the perpendicular part. I just say and write u perpendicular. So how to find these two components of u? So the u parallel is also known as the projection of u onto v. So sometimes we call this u parallel the projection, vector projection of u onto v. You know the meaning of projection in English. Okay, so how to find the u projection of u, or u parallel and u perpendicular? So here is the formula. So u parallel is basically magnitude of u times cosine theta times the direction of v. The direction vector of v is just v divided by the magnitude of v. So the first part, so this part is just the magnitude of the u parallel. And the second part, which is the vector part, is just the direction. Okay. And then u perpendicular, once you have the u parallel, u perpendicular is equal to u minus u parallel. Okay. Okay. So that is also something important that we use a lot in some situations for solving problems. Is there any question? So for example, let me ask you, since you don't ask any question, I'm asking you. So imagine that I give you two vectors, u is 1, 0, 3, and v is 1, -1, and 1. So now the question is find the parallel part and the perpendicular part of u with respect to v. So in other words, find the projection of u onto v and also the perpendicular part. So you just, okay, so here, but you need to find the theta. And that's an important question, how to find the angle between two vectors in general. So I didn't teach you how to find the angle. So finding angle is related to the dot product. Okay, so here is the relation. Whenever you have two vectors, here is very important, super important relation. U dot v, the dot product, is equal to magnitude of u times magnitude of v times cosine theta. So that means whenever you have two vectors and you have the components, if you want to find the angle between them, you just find the dot product, because from here you can, it follows that cosine theta, it is just a consequence of this formula. Cosine theta is u dot v divided by magnitude of u times magnitude. Given that u and v are non-zero, because if it is one of them, it's zero, then it doesn't make sense. Okay? So once you have the dot product, then you can tell me the cosine. Right? So let me just put, before doing this example, I can do this later, but we will do it. I post it here. Okay, so remember that u parallel was this formula, absolute, the magnitude of u times cosine theta times v over magnitude of v. Now, if you use this formula to find cosine, then you can write another formula for u parallel. I'm just subbing cosine theta here in this formula. So if I call this the formula 1, this is the formula 2, it follows from 1 and 2. If you combine 1 and 2, then it follows that u parallel is equal to absolute value of u, or the magnitude of u, times, now instead of cosine, I just put u dot v over u times v times v over v. Now the good thing here is that the absolute value, the magnitude of u is gone. They cancel out each other, and what you get is u parallel is equal to u dot v over magnitude of v times magnitude of v times v. Here is, this formula is more simple than the above formula, because if in this formula you just need to compute the dot product. You don't need to use cosine. Okay, is that clear? So let's do this with this example. So recall that u parallel is this formula. So we know that u parallel, we want to find u parallel, is u dot v over magnitude of v times, or you can just say magnitude of v squared, which is the same. Okay, now what is u dot v? Is 4 over, what is magnitude of v times magnitude of v? So here's is something, I mean, it's not too tricky, but you can also write magnitude of v in terms of dot product. Can someone tell me what is the relation between magnitude of v and the dot product? Or magnitude of any vector? So so no, before doing that, just tell me what is the magnitude of v here. Magnitude of v? Yeah. Forget about dot product. What is the magnitude? Root 1 plus 1 plus 1. Yeah. Square root of 3. What? Square root of 3, right? Yeah, yeah. So let us finish this. So you have a square root of 3 times square root of 3, right? Which is just 3. I think it's 2. Oh. Square root, I mean. So it's 4 over 3 times v. What is 4 over 3 times v? It's just 4 over 3 minus 4 over 3 and 4 over 3. Is this clear? And you know how to use this formula, basically. Now, what I wanted to tell you is that, recall that if you have a vector like u or v, say v is equal to v1, v2, v3, then v dot v is what? Is v1 squared plus v2 squared plus v3 squared. But this is nothing but magnitude of v squared. So important lesson here is that v, for any vector, v dot v, the dot product of v itself is square of the magnitude. Okay. So for example, in this formula, then the denominator is just v dot v. You can also write v dot v in the denominator. Okay. I mean, this guy is the same as v dot v. Because v dot v is magnitude of v squared. Okay. Okay, guys. So this formula is important and useful, the formula for cosine theta, which is related to the dot product, because sometimes they give you two vectors. For example, consider these two vectors. Now the question is, what is the angle between these two vectors? I mean, this is another question, totally different question. So you have two vectors, and the question is, what is the angle? Find the angle theta. So how to find it? We know that u dot v is absolute value of u times absolute value of v times cosine theta. So cosine theta is equal to u dot v over magnitude of u times magnitude of v. Now, what is u dot v? U dot v is just 4 over what is u dot v is 4, yes. What is the magnitude of v? Sorry, give me a second. And the first thing we do in dynamics in the Newton's law for motion. So we have three laws. I mean, three Newton's law. So what is the first law? Open the textbook. So what is the first Newton law? You remember? So Newton's first law of motion. It basically says that if there is no net force on an object, so the object will be either at rest or it moves with constant velocity. So if the net force, you can somehow say that maybe this is a special type, kind of the second law, because second law is more general. But anyway, so if there is no external force, net force on an object, so it's either at rest or it moves with constant velocity. That is the first. What is the second law? The second law is something that we use a lot for solving problems. So the second law, I'm writing it down here. What is the second law, guys? Do you know? Does anyone know?
The second law,
Yeah.
F equals to ma. That's the third law.
No, that's the second law. That's correct. That's correct. So now, so here there are two concepts. One is this: the acceleration of a body is proportional to the net force. That is the first concept. The second concept is that the acceleration, let me just write it down. So the acceleration is proportional to the net force. F is net force. The second concept is that the acceleration is proportional to the inverse of the mass of a body. And Newton concluded that the acceleration is actually equal to the net force over the mass. So in other words, as you said, m times the acceleration is equal to the net force. Okay. So what is the unit of force from here, from this equation? So what is the units of force from this equation? Can you tell me? Just using this equation, what is the units of mass? Like kilogram or, yeah. So in general, so the unit of force, so I just, instead of for unit, I just put bracket, F is equal to the unit of mass, so I just put M times the unit of acceleration. What is the unit of acceleration? Is meter over second square, or for unit, for meter, which is length, I just put L over secant square, T square. So the unit of force is mass times length over time square. Okay. So for example, we can use like kilogram meter secant. This is the standard units, SI units. And 1 kilogram meter over secant square is basically what is called 1 Newton. So 1 N is 1 kilogram meter over secant square. Okay. So another important thing is the weight, which is the gravitational weight. So weight, or the gravitational weight, it is just W equal to the mass times the gravitational acceleration, which is about 9.8. So G is about 9.8 meter per secant square. So weight is basically the gravitational force of any matter on the Earth. On the Earth, that is important. It's not other, Because if you go like to the moon, that would be different. Okay. So, and the third law says, do you know what is the third law? Anyone know?
It's about the last PMS.
No, actually, about the forces.
It's about net force.
Yeah. So it says that basically, if you have two bodies and one body push like a force in the other one
Give
return the force with the same magnitude by opposite direction. Okay. So I want you, or maybe I can share this screen. So here is a good example. Look at page chapter 4, 4.4, page 159. Page 159 and of the textbook. Do you see this? Can you find it in your books? Okay, so here is a good example. So you see a person, a physics prof. So she pushes a cart with equipment, some equipment, and we know what her mass is. Her mass is 65 kilogram. The cart's mass is 12 kilogram, and the equipment mass is 7 kilogram. So now the question is, calculate the acceleration produced when the prof exerts a backward force of 150 Newton on the floor. So that means when she walks, she exerts this force of 150 Newton on the floor. Backward, that means in the horizontal direction. Okay? And all forces opposing the motion, such as friction on the cart's wheels and the air resistance, total is 24 Newton. So now the question is, what is the acceleration of the cart? So here, if you look at this picture, so first of all, from the third law, so if you just look at the teacher, so she pushes the floor, and you can see the force of her foot. She here is denoted by F, index foot. So F foot is the force of the teacher on the floor. And F floor is exactly the opposite of the foot force, okay? But I mean, the same magnitude, but in the opposite direction. So from the third law, we can see that the floor, force of the floor is equal to exactly to 150 Newton, but in the opposite direction, which is the direction of the moving of the teacher and the equipment. Okay. Is that part clear? So just look at the teacher. There are two forces equal to each other, but opposite direction. One is the force of her foot to the floor. Another is the force of floor to her. Okay? And that is the force magnitude is 150. Okay, but we have also friction that is totally 24 Newton. So from here, you can compute the acceleration. So what are there are two forces here, external forces. One is the force of the floor, and the other is the force of friction, right? So these are the net, basically the external forces. So the net force would be 150 minus 24 in the right horizontal direction. You got it? And you have the total mass, which includes the mass of the teacher, the equipment, and the cart. So what is the acceleration? So you can use the Newton law because the acceleration is the net force over the mass. The net force is 150 minus 24. As you see in this picture, the only external forces are the force of the floor and the friction. Okay? And the mass is just the sum of the mass of the teacher plus equipment plus the cart, which is 84 kilograms. So when you divide the total force by mass, you get 126 over 84, which is 1.5 meter per second square. So now I'm asking you this, given that this is the acceleration, how long she goes with this equipment after, how far she goes after, say, 1 minute?
So the initial velocity is 0.
Initial velocity is 0, yeah. So now we have to use the kinematics equation. So what was the equation of kinematics?
X t equals to.
When you are in one dimension, you just have one component. So you don't have to worry about vectors. So you have x equal to 1/2 of at squared plus v0t, which is the initial velocity, plus the initial position, x0. So here, a is what? Let me just, what is a? Is 1.5 meter per, and v0 is just, we assume that it's 0, x0, we can assume it's 0, because I want to find how far they go or she goes. So x would be equal to 75, 0.75 times t squared. That's it. So when t is equal to after a minute, sorry, 60 seconds, so x would be 0.75 times 60 squared, which is
200, 2,007.
Hmm?
And 700.
the total.
Yeah, 2,700.
That's a lot.
Because you're like accelerating for the whole minute.
Yeah,
But that should be fast.
that's 2 kilometers.
1 minute.
Yeah. Now, what is the final velocity after 1 minute?
90 meters per second.
Ninety meter per second. Can you convert it to kilometer per hour?
26.5.
Hmm?
26.5.
26.5 kilometer per hour. I don't think so.
Yeah, that's not right. I mean, that's 26 or 3.6. Oh, 3.6, yeah, 25.
So you basically have to.
I was 3.6.
Let's see. So this is meter per second. Okay, if you want to convert it,
Yeah.
you divide by 1,000 first. And multiply. So you have to multiply.
Yeah, that should be 300. Yeah.
So this would be, if you multiply, would be
106.1. Yeah, 25.
you have to multiply.
We use 92.
Yeah, we use
Lines.
90 to directly.
But the answer is not this.
The answer is not right. The answer is not 26.
Yeah,
It's
yeah.
25. It's 25.
No, why 25?
It's 324. What?
Wait. Oh, my bad. Sorry. 224.
What is it?
224.
200. That's a very fast speed. Kilometer per hour. I cannot reach it with my car. Okay. Now let's go to the next part. So the next part, I want you to compute this. Calculate the force the professor exerts on the card using the data. What is the force that she exerts on the card? So here is the hint is like this. If you, here you see system 1 and system 2. System 1 is the whole prof and the cart and equipment. Okay. But here, but for this second part, we just look at system 2. System 2 is just the cart with the equipment on it. Okay. So what are the external forces on this cart? Is the force that the prof pushes the cart and the friction. So we don't know the force that the prof exerts. We want to find it, but we know the friction and we know the acceleration. That's important. That's the key. So we don't know the force of the prof, but we know the acceleration. So here we do kind of opposite of we did for the first part. For the first part, we knew the total force and we compute the acceleration. Here we know the acceleration, we want to find the force. So based on this, what is the force that prof exerts on the cart? So you can use this formula. The acceleration is net force over m, the mass. So the net force is m times acceleration, and acceleration is just 1.5.